I'm going to illustrate how to find the distance between 2 points, and I'm going to show you on the plane and then give you a formula and go over some examples. Alright, so if you look here at this plane, I have x1, y1, and x2, y2, and I'm trying to find the distance between the 2 points. So I'm trying to find how far this is, and that's what I'm going to call d. Alright, now this looks like a difficult question at first until I start thinking in terms of triangles. Because if I think in terms of triangles, so if I make a third point here, and that third point is drawn from a vertical line to that top point and a horizontal line from the bottom point, you see I make a triangle. Not only that, I make a right triangle, okay? And the length of this side, we'll call it A, and the length of this side, we'll call it B. And the reason I did that is because the world's most famous theorem, the Pythagorean theorem, says that for a right triangle, a squared plus b squared, the square of the two sides has got to equal the length of the hypotenuse, which I call d. So a squared plus d squared equals, a squared plus b squared equals d squared here. Alright, so if we can figure out what a and b are supposed to be, then I can figure out what my distance should be. Okay, so actually this a is just the distance that x goes from my first point to the second point. So a here is actually x squared minus x1 in absolute value, but since I square it, I don't really have to worry about the absolute value there. And in a similar way, my b is y2 minus y1 quantity squared, and that equals d squared again. So the distance formula then, which is d, is simply taking the Pythagorean theorem, x sub 2 minus x sub 1 quantity squared, and y sub 2 minus y sub 1 quantity squared, and then taking the square root of all of that, right? Because I had d squared equals this expression. So when I take the square root of both sides, and since this is always positive, I only have to worry about the positive square root, and there's my distance formula. Okay, I'm going to go over some examples to show how to apply this, but it's really just a matter of just plugging it into the formula. Okay, so here I'm trying to find the distance between the following points, and for part A, I have -1, -2, and 2, 2. Okay, so it doesn't really matter which one you call your x1 and your y1, as long as you're consistent. So you take distance, which is going to be x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared, and the square root of all that, and it's just a matter of plugging in the numbers. So for x2 I have 2 minus a -1, that's squared, plus my y's I have 2 minus a -2 quantity squared, taking the square root of everything there. So 2 minus a -1 is actually 2 plus 1, which is 3. So 3 squared, we get 9. And then 2 minus -2 is actually 2 plus 2, which is 4. So that was 16. So I have the square root of 9 plus 16, which is the square root of 25. And so here, actually I get exactly 5 as the distance between the 2 points in my graph. Okay, now for part B, we do the same thing. So I'm just going to jump to plugging it in. I have x2 being 2 minus a -8 quantity squared, plus my y2 is 11 minus 3 quantity squared. So that's 2 plus 8 quantity squared, so 2 plus 8 is 10, so that gives me 100. And then 11 minus 3 is 8. 8 squared is 64. So I get the square root of 100 plus 64. And I would be very careful. It's very tempting to say, well, that's just 10 plus 8. And that is not true. Remember, you cannot distribute a square root like that. This is actually the square root of 164. Okay, now how do I simplify 164? Well, let's see. You got to start factoring. So I notice that I can take a 4 out. And if I take a 4 out of this, let's see, you have to divide it maybe, but I think you get 41. Okay, and then 4 is 2 times 2, so and 41 is prime. So 164 is the same as 2 times 2 times 41. Whatever shows up twice can come out. Alright, so I'll write that here. You get 2 times 2 times 41. Since the 2's show up twice, I have 2 square root of 41, and that's about as simple as we can get. So it's not as pretty as 5, but it still is the distance between these 2 points. I hope this makes sense. This is a great formula to know. If it's hard to remember, I think the Pythagorean theorem idea really makes it clear. If you have any questions, I'll be glad to help, and thanks for watching.